Hello, in lesson 110, we're going to learn about different transformations, reflections. And just like before, you're going to be able to, again, know the difference between a rigid and non-rigid transformation and identify the transformations for these functions. So let's look at our example. Well, let's go over, first of all, the word transformations again. Remember, transformation simply is a way of saying that we're changing something, okay? We're changing the shape, size, or the position of a parent function. If I do not change the size or the shape, that's referred to as a rigid transformation. Like last time, we talked about translations. Today, we're going to talk about reflections. So a reflection is an example of a rigid transformation. A reflection is simply, again, flipping an object over a line that acts again like a mirror. So if I flip this horizontally, as you see in this picture right here, that is going to change again all of the x and y values to have a different x but the exact same y. So specifically the opposite x will give you again the exact same y coordinate. And that would be a horizontal flip. We're going to be looking again at reflecting and flipping things also vertically. So there's two ways to flip something. There's the vertical reflection and, like I said, a horizontal reflection. So right here, let's stick with the horizontal reflection. So again, let's label this again as f of x. So we have this function f of x, and we want to flip it again horizontally. So we'll call this g of x. Well, to get f of x and to flip it vertically, to flip it vertically, which is going to be across, see that we're jumping across the x-axis. All we need to do is simply multiply the parent function by a negative. So we simply put, again, a negative in front of it, and that's going to cause a reflection over the x-axis, a vertical reflection. So for example, let's look at some examples of this. So in like number 1, this is an example of a vertical reflection. So, sorry, if you look at, trying to get my pens to work, here we go. If we discuss again what we learned on the last, on 1.9, the minus 8 and the positive 8 and the minus 4 are going to result in a slide. That's going to result in a translation. The 4 is going to slide our parent function, which in this case is x to the third power, 4 units to the right because it's positive. So again, it moves in the opposite direction. The 8 is going to shift our x to the third power 8 units up. And what the negative sign is going to do is simply cause, again, which is the new part today, is simply going to reflect vertically. So this is going to result in a vertical reflection, which is across, a reflection across the x-axis. Another example of this. If we have 1 over x plus 7 minus 9 and a negative in front of it, okay? So let's discuss again what this does, and then we'll talk about what the negative sign is going to do. So right here, if you recall from last time, adding 7 to the x, that's going to result in a horizontal shift. So we're going to slide again our reciprocal function 7 units in the opposite direction of what add normally does. So it's going to be to the left. The 9 is going to shift again 1 over x, 9 units down. And that negative sign, because it's out here, that's going to result in simply reflecting vertically, which is going to jump over the x-axis. So let's now go back to a horizontal reflection. Now, to flip it horizontally, which is going to jump over the, as you see right here, we're jumping over the y-axis. So this is going to go across the y-axis, a horizontal reflection. We're going to multiply by a negative again. But that negative is not going to be on the inside, on the outside, I'm sorry. It's going to be on the inside with the x. So our functions will look like this. Every parent function will multiply the input value with a negative sign, and now we'll flip it again across the y-axis, a horizontal reflection. So for example, on number 3 in our notes, this is going to result, because the negative sign is on the inside, this is going to, again, flip this, reflect our square root function across the y-axis, again, which is a horizontal flip. And the plus 4, well, the plus 4, remember, it's going to result in a shift of 4 units up, because it's on the outside, so that's going to move it up 4 units. Here, in order to do a horizontal shift and a horizontal reflection, it has to be written again separately, separated by, again, parentheses. So like right here, the x minus 4 is going to shift the square root function 4 units to the right. Because it's minus, that's going to shift it to the right. And the minus sign, because now is on the inside, like last time, that's going to result in a horizontal reflection. So we're going to flip it horizontally, which is going to jump over the y-axis. Now, if it's not written like this, like example number 5, I have to write it like that in order for it to again match up to what we discussed before. Because right now, adding 1 on the inside, we would think, oh, adding should shift this again to the left. But because of the negative sign not being separated and all of this being joined together, it's actually telling us the wrong piece of information. So to accurately get the correct translation, we have to factor out the negative sign and divide the negative sign out of both of these terms, still inside the square root, of course, but out of both of these terms. So we have a positive x, which is what we need. We cannot have a negative x right there. We need a positive x, and we end up with a minus 1. So now with our x being positive, this operation is now correctly telling us what direction we're moving. With the negative x, it's giving us the wrong information of what the plus 1 is actually doing. We're not actually adding 1 to a positive x. We are subtracting 1 to a positive x, which means, again, that we're going to shift our square root function 1 unit to the right. So it's not shifting it to the left, it's shifting it to the right. And the negative sign, of course, is going to cause a reflection. And we're going to flip this horizontally, which is over or across the y-axis. All right. So let's look at our last example. On our last example, we see again that we have two transformations inside. So because we are subtracting 3 to a negative x, in order to get the correct direction, we want this to be a positive x. So we're going to factor out that negative sign. And we have x plus 3 inside the square root and the positive 8 on the outside. So the negative sign, that's going to result in a reflection. And because it's on the inside, it's a horizontal reflection, which is going to go over the y-axis. Now, the plus 3, again, added to the x, this is going to cause a horizontal shift. So we're going to shift 3 units to the left because we're adding, so that's going to be to the left. And the 8 that's on the outside, that we're adding on the outside, that is also going to result in a shift of 8 units, but up this time. So these are the reflections. These are the translations. These are the three rigid, non-rigid transformations of this function. Again, rigid transformations. And of course, the parent function, which I didn't write on any of this, the parent function is y is equal to the square root of x. So the square root function. Now, the next part again is to work backwards. If I give you an equation, is to identify what the transformations are. So right here, notice that this is an absolute value function. Our absolute value function again is always a v that is upwards, again where this turning point, the vertex, is at the origin. Notice first of all that this graph is upside down, and because of that we're multiplying obviously by a negative. Now because it's a vertical reflection, again it's being flipped across the x-axis, a vertical reflection, that negative sign is going to be put on the outside of our absolute value. So if all I'm going to do is flip it upside down like this one, that would put a negative on the outside like so. Now to identify the horizontal translations, we simply have to look at our focal point, which is this one right here, and see how it moved from the origin. So it's been moved 4 units to the right and 6 units up. So just focusing on that, the equation would be f of x equals x minus 4 and then plus 6 on the outside. But that's only going to move again the v to that location. In order to make it upside down, like I said at the beginning, I have to put a negative sign in front of that. So this would be the equation for this. Now this is our cube root function. Normally our cube root function, x to the third power, that again is increasing. We'll see from the parent function is increasing. Notice that this graph again is upside down. So in order for it to be upside down and decreasing instead of going up, we simply multiply again a negative to the outside of this. So we don't group the negative again with x to the third power. So for this one, since it normally again intersects the origin, it is now being, that point is now here, which is again shifted 6 units to the right. The function for this would be negative x minus 6 in parentheses, because it's a horizontal shift, to the third power. So this would be the equation to this function here. Now this function is the square root function. And normally that square root function again is at the origin and moving upwards. Since this function is obviously upside down and it's decreasing, the way that I make it be upside down again is by simply putting a negative on the outside of the square root, and that will make it again upside down. Now again, normally this starting point, as I'm highlighting it here, is usually at the origin. So we're not only going to flip it upside down, but we're also going to slide it 3 units to the right and 4 units up. So the equation for this function on the graph would be negative, to have it upside down, the square root of x minus 3 to slide it 3 units to the right, and then the plus 4 outside to slide it upwards. Now, to have the graph again upside down, the square root function upside down, so again the parent function is the square root, and in order to have it upside down, again I've simply put a negative sign on the outside of the square root. But to also have it pointing in the opposite direction, notice that this one is not only upside down but also pointing to the left, that's going to result, let me move this out of the way and let me write it right here, that's positive square root. That's going to result in having a negative on the inside with the x. So here, where I want to have it upside down and also pointing on the left, have it do this, be upside down, but also point on the left, is going to result in putting a negative sign on the outside and on the inside. So for example, to get this graph right here and have the graph point in this direction, that would require a negative on the outside of the square root and a negative on the inside of the square root. And now to consider again the new position of this, since it originally is at the origin, this point is originally at the origin, we see that it's being slid 6 units down. So the function would be negative square root of negative x, and then the minus 6, because it's vertical, it goes on the outside, minus 6 to slide it 6 units down. So here another example. We're sliding it again. We're flipping it upside down, and we're also making it point to the left. So again, that's going to result, again, we want it to be pointing in that direction. So that's going to result in having a negative on the outside and a negative on the inside. Since we're sliding this thing from its original position of 0, 0, to this new location, which is 8 units to the right and 6 units down, our function would have negative square root negative, and in parentheses we'll have x minus 8 to slide it 8 units to the right, and then minus 6 on the outside to slide it 6 units down. So anything that you do on the inside, again, is going to affect it horizontally, and anything you do on the outside of the grouping symbol, which in this case is the square root symbol, is going to affect it vertically. So this would be the equation for this graph here. That's upside down, pointing in the opposite direction, and translated and slid 8 units to the right and 6 units down. One more. On this one, it is not upside down. All we're doing is simply having the graph pointing in the opposite direction. So that only requires, I'll do it here again. Since the original function again points to the right, that's again the square root of x, in order to have it pointing in the opposite direction, again to the left, that simply puts a negative sign inside the square root with the x. Now, since it's obviously been moved 3 units to the right and 7 units up, that's going to result in the following. So we have a negative because, again, what's pointing in this direction is pointing to the right, and in parentheses we're going to have x plus 3, since we're sliding it 3 units to the left, and on the outside of the square root, plus 7 to slide it up. And this would be the equation. And there, that concludes the examples on reflections and how reflections work. Now, if you have any questions, again, please send me a message on Remind or an email. And I, again, appreciate you watching, and I hope you have a great day.